Hello, in this video I'm going to solve the following problem for you. So let us read the problem together first. Give a story proof that sigma k goes from 1 to n, k times n choose k squared equals to n times 2n minus 1 choose n minus 1 for all positive integers n. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you find the problem hard, the book has provided you with a hint for this problem, which I will show on the next slide. So if you want to think about the problem without looking at the hint, just pause the video at this moment. Otherwise, you can go and see the hint. Consider choosing a committee of size n from two groups of size n each, where only one of the two groups have people eligible to become the chair of the committee. Okay, so let us solve the problem now. I want to solve the problem in two different ways. One, I want to follow the story proof which is mentioned in the book. And then for the second method, I want to show you how you can use binomials theorem, Newton's binomial theorem, to be able to prove this equality. Okay, method one. Story proof, yes. So we have to tell a story to ourselves so that the solution to that story actually gives rise to this equality. Okay, so my story is this. Let us have m mathematicians. So I have mathematician number 1, mathematician number 2, mathematician number n, and then I have n physicist, physicist number 1, physicist number 2, up to physicist number n. So in total, I have 2n people, and I want to set up a committee so that n people are in that committee. Yes? But the constraint is that the boss should be a mathematician. The boss, the chair of the committee, should be a mathematician. Okay, in how many ways I can do that? In how many ways? Can one set up the committee? So that is our story. Okay, and we want to solve this problem in two different ways. One easy way. Okay, so my goal is to choose n people out of 2n people, but the point is that one of these n people should be the boss, and that boss should be a mathematician. So the easy way to solve this problem is to choose that one person as the boss. So in how many ways I can choose the boss? The number of ways that one can choose the boss. What is that? This is just simply, we have n mathematicians, I want to choose one of them, so it is simply n. Okay, now that the boss is known to us, I have n minus 1 people that I am supposed to choose from 2n minus people left. Yes? Okay, so the number of ways to choose the rest. What is that? I have 2n minus 1 people left, and I want to choose n minus 1 of them. Okay? So the answer to this question is, by product rule, is simply, so the answer is equal to n times 2n minus 1 choose n minus 1. Okay, so that is one way of answering this question. Okay, but the other way to look at the same problem is to think in that way. Let us say that in my choice, because I want to choose n people, and one of them should be a mathematician, because the mathematician should be the boss. So I will follow like this. I would say that, okay, I choose one person from mathematicians. I have n number of mathematicians. I choose one of them. And then in how many ways I can choose the boss, because I have only one mathematician chosen, there is only one way for me to choose the boss. And now I have to choose the rest of my group, which means that I need to choose n minus 1 people out of n physicists. Okay? Or I can choose 2 mathematicians, but then I have 2 options for choosing my boss. So it is 2 times n choose 2, but then the rest of them should be chosen from physicists. So it means that n minus 2 should be chosen from n physicists. Let us continue. Or I choose 3 mathematicians, and now I have to choose my boss. So I have 3 options to choose out of those 3 people that I chose for being from mathematicians. And then the rest of the group, meaning n minus 3 of people, should be chosen from physicists. And then this can continue. For example, one possibility is that I choose all n people from mathematicians. Then I have n choice for choosing my boss. And of course, no one should be chosen from physicists. Okay, so I hope that you agree with me. This sum is also counting the same thing that we are interested. So the result of that and that should be the same. Okay, so if I want to write this, so it means that the answer can also be expressed as this sum, that I can write it as a sigma. So this becomes sigma k, and then I have n choose k, n choose n minus k, k goes from 1 to n. Okay? But then this is also a famous theorem that these two numbers are the same. So we know that n choose k and n choose n minus k are equal. So then it means that this sum can be written as, so let me write the same color. So this becomes sigma k goes from 1 to n, and then I have k, n choose k squared. Okay, so on the one hand, the answer is this. On the other hand, the answer to the same problem is this. So this means that these two quantities should be the same. And that is exactly what we want to show. We want to show that this expression is equal to this expression, and we are done. But now, my goal is to show you how you can prove this analytically without actually telling a story. Okay, so now let us prove it using binomial theorem. So method 2, using binomial theorem. Okay, so let me remind you the formula for the binomial theorem. So if a and b are real numbers, and if n is a natural number, then a plus b to the nth is equal to sigma k goes from 0 to n. I have n choose k, a to the power of n minus k, b to the power of k. So that is the formula, that is the binomial theorem formula. Okay, but now what I want to do, I will start from 1 plus x to the power of 2n minus 1, okay? And I want to expand this using binomial theorem. Okay, so I give the role of a to 1, I give the role of b to x, and I give the role of n to 2n minus 1, and I would write this. So if I do that, it becomes sigma k goes from 0 to 2n minus 1, and then I have 2n minus 1 k. A is 1, so it doesn't matter. This is just 1 to any power. It is just 1. I don't need to write it down. Then it becomes x to the power of k. And now I ask you, what is the coefficient of x to the power of n minus 1? So what's the coefficient? It's very simple, because you know that k goes from 0 to 2n minus 1. So at some point k reaches to the value of n minus 1. So then it becomes x to the power of n minus 1 that I need. And then, of course, this would be its coefficient when k is n minus 1. So the answer to this question is extremely simple. 2n minus 1, n minus 1. So that is the coefficient. Oh, sorry, I forgot to write that. Okay, so 2n minus 1 choose n minus 1 is the coefficient here. But I can calculate this coefficient in a different way. How? Let me just do it a little bit differently. So I would say that x to the power of 2n minus 1 can be viewed as 1 plus x to the power of n multiplied by 1 plus x to the power of n minus 1. Yes, because if you multiply them, I will get this back. But now I want to bring the notion of derivative for the second part. So I would write it as this. 1 plus x to the power of n multiplied by 1 over n, 1 plus x to the power of n derivative. Yes? Why is that? Because if I take the derivative of that, it becomes n times 1 plus x to the power of n minus 1. This n and that 1 over n uncancel, and I will have these two expressions that I had already. Okay. But now what I want to do, I want to use binomial theorem once more for this part. So I want to give the role of a to 1, I give the role of b to x, and of course n is the same as n. So what can I do? 1 plus x to the power of n can be written as sigma, but because I have used index k, let me change my index here. So let me choose m. So m goes from 0 to n, and then I have n choose m, x to the power of m. And now if I ask you what is the derivative, it's extremely simple. I just take the derivative term by term from the right side. So it becomes m goes from 0 to n, and then this m goes down, and then I have x to the power of m minus 1. So this m goes down, n choose m, x to the power of m minus 1. But of course you see that the first term, m is 0, so the first term is actually 0, so it doesn't matter if I start from 1. And then because I want to multiply these two, I want to change the name of the index. So let me change the name of the index from m to l and write it from 1. Okay, so then this is simply written as sigma, l goes from 1 to n, and then I will have l, n choose l, x to the power of l minus 1. Okay, so and now I will set up this. So I multiply this by that, and then I multiply by 1 over n. So I multiply this by that, and I multiply by 1 over n. Okay, so I can continue here. So this expression, because of this calculation that you see, now becomes equal to 1 over n sigma. M goes from 0 to n, n choose m, x to power m, multiplied by sigma, L goes from 1 to n, L, n choose L, x to the power of L minus 1. Okay. So if I want to combine them, so it becomes 1 over n, sigma, m goes from 0 to n, L, n choose m, n choose L, x to the power of m plus L minus 1. Yes, so what I did, I'm just multiplying them. Oh, I have to write 2 sigmas, sorry. So let me clean this. I forgot to write 1 sigma here. So 1 over n sigma. M goes from 0 to n, and the other sigma L goes from 1 to n. Okay? So I just multiplied them term by term. This is what I get. But the point is that I want to find the coefficient of x to the power of n minus 1, again using this expansion. So it means that I am asking myself when this power becomes n minus 1. So I would write it down. So I ask this question, m plus l minus 1, for which value of values for m and n, it becomes n minus 1. Of course, this happens if and only if m plus l is equal to n. But you know that m goes from 0 to n, but l goes from 1 to n. So let me set up the table so that we see how it works, okay? So let me set up here and m. The first value that I can choose for L is 1, because L cannot be below 1. And then, because I want to have the sum to be n, then this m should be n minus 1. Yes? The second value that I can choose for L is 2, and then m has to be n minus 2. The third value is 3, then it has to be n minus 3. And my list continues. The maximum value for L is n, okay? But if I choose that one L for n, if I choose n for L, then m becomes 0. Is that acceptable? Yes. Okay, so these are the choices that I have. Okay, so this means that the coefficient of x to the power of n minus 1 based on this calculation is equal to, I need to add all these coefficients for these values, because for these choices I will have x to the power of n minus 1. So this means that the coefficients of all those terms involving x to the power of n minus 1 will be added, but all of them are supposed to be multiplied by a factor of 1 over n, because this factor of 1 over n can be actually moved here. Okay, so I would write it like this. So it becomes 1 over n, and then I put L equals to 1, m equals to n minus 1. Okay, so if I put L equals to 1 and m equals to n minus 1. So, and if you don't mind, let me write this next to this one. So this becomes 1, n1, and then I have n minus 1. The next one will be L is 2, so it becomes n choose 2, and then I will have m is n minus 2. And then the next one will be 3, n choose 3, and then I have n minus 3. And this list continues so that the last one is n, and I have n 0. Okay, so that is the coefficient of x to the power of n minus 1, which is equal to 1 over n sigma. So let me write k again. So k, and then I have nk. But you see that all of these ones are equal to the first term, exactly because of the same reason. n1 is equal to n minus 1. I don't know, n2 is equal to n times n minus 2, and etc. So I can write this as a power of 2, and then I would say k goes from 1 up to n. Okay, so on the one hand, the coefficient of x to the power of n minus 1 is this expression. On the other hand, the coefficient of x to the power of n minus 1 is this expression. So this means that this expression and that expression are equal. And if I multiply everything by n, this n will be cancelled here and will appear there. So this means that this expression is equal to that. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.